We're very happy to be here today. Thank you very much for having us. My name is Edward Maddox, owner of Maddox Architecture. And our company basically does two things, and we try to do two things well, and we keep buildings safe and dry. So the safe is local law 11 and making sure that nothing is falling off the building, and dry are leak investigations and roofing and waterproofing consulting. And we specialize in those two areas. We don't deviate from those areas, and we focus in. And today what we're going to do is, there we go. We're going to talk to you about why buildings leak, what we can do to prevent leaks from happening, or if you have a leak, what should you do? Because I think we all know that leaks can become very litigious quickly, and you want to make sure that when people get upset that you're responding quickly and making sure that you're not ignoring a problem. So we have a couple of learning objectives that we want to, it's not AIA, but we're going to try to teach people things. And by the way, if anyone needs to ask a question, please ask at any time. Don't feel bad about interrupting. It's more of a dynamic. What's that?
Don't worry.
Yeah. It's a dynamic conversation. Okay. I really hope that it's not, we gave you a lot of nice, pretty pictures to look at, but we want to make sure that you're getting something out of this presentation to help you manage your buildings. So what we're going to do is we're going to talk about a couple of tools that we use for leak investigations. We're going to talk about why buildings leak. We're going to talk about common failure points in a building. We're also going to talk about maintenance and prevention. Okay, and what we could do to not have the leaks happen, instead of like waiting until it's too late. So, anyone, show of hands, anyone ever get a phone call about a leaky building? Anybody? Right? When you get the call, okay, it's usually at a bad time, like, oh, it's Christmas Eve, 5 p.m. Everybody went home and the building is leaking, and so when you begin, the most important thing is to make sure that you have really good communication with your resident manager or your building superintendent. When the leak happens, you want to have him or her go up to the leaky area, take photographs, take any kind of videos that the person might be able to take, and really just try to document where the water came in, and then they would call us and we would come and take a look at the building. But really, when the leak happens, that's one of the most important times. We even tell people, take little bits of tape, little Post-its, little pencil or something. If it's not an obvious, like a gusher where the water's really coming through bad. But you want to make sure you're documenting where the leaks are taking place so that when your professional comes in to diagnose, they have some kind of place to start. So, and leak investigations are, a lot of the times they're very difficult. A lot of times what will happen is, you have a minor leak and we'll say, all right, we'll get a contractor, he'll come in, he'll fix it. Okay, has anyone ever heard of a contractor say, you need a whole new roof? We need a whole new roof. And these days roofs are, easily six figures, if not a lot more. Exactly. Could be $500,000, could be $1 million for a roof these days. And by the, so if you say, oh, we need a new roof, well, maybe you didn't. Maybe it was one little point. Maybe it was one location. So it's always good to have a professional come in and say, this is where your leaks are coming from, before you start spending a tremendous amount of money on making repairs. So, what we like to do is we want to understand, is the leak coming from quote unquote the roof or the wall? If it's a window leak, usually it's the wall. If it's somewhere up here, it's usually the roof. But to be honest, a lot of times it's an interface between the two. And people think, oh, roof leak, roof leak. I actually got into leak investigations because I used to do a lot of roofing, and everyone would say it's a roof leak, but a lot of times it wasn't. So the takeaway here is before you spend $500,000 or $1 million on a new roof, diagnose the problem first. All right, let's keep going. Any questions so far? I know we're in the beginning. All right. So like we said earlier, we want to make sure that we're getting all our photos and videos ahead of time. We want to know, is it a condominium? Is it a commercial building? Is it a private residence? Because all of the different types of buildings could impact or affect the how you would go after doing the diagnosis, okay? I hate to say it, but a lot of times it's a high-end building. It's usually in the penthouse a lot of times. Who lives in the penthouse? Rich people, yes. And rich people not only want their problems fixed right away, but you also have to coordinate. You can't just go in. You can't just show up and, oh, we'll take care of this now. So there's a lot of coordination involved with, depending on what type of building it is. A lot of times, if we have a resident manager or a superintendent there to point things out, that's always the most helpful for us. And then the other thing we like to do is if a building has multiple leaks, a lot of times it's not just one. It could be a building that, let's say AKAM is taking over from another property manager and they have a dozen leaks. We deal with that all the time. So you want to make a leak log. What we'd like to do is we'd like to track everything. We like to show when we did spray testing, when we were able to recreate a leak, how long did it take? So there's a good, you want to keep everything very organized. And sometimes we also do leak investigations on new construction buildings. And when that does happen, which it happens a lot more than you would imagine, we have to make sure that we're dealing with the correct trade that would be affected, either roofing, facade, windows. Then the other thing we like to do, let's say the building has multiple leaks. Yes, please.
Would your company be doing the leak test?
Yes, so
the third party.
That's a very good question. So depending on how difficult it is, if it's something that we can reach physically, and we have a bunch of case studies that we're going to show you in a few moments. If it's something that we can reach ourselves, we do the testing ourselves. We've learned that we'd like to go with a two-person team so that if one person is upstairs spraying and it starts leaking, it's not flooding out the person's apartment. So we'd like to have one person spotting and then one person testing. When it's a more complicated leak, let's say it's let's say it was right here. We can't get to this, and we would have to get a contractor involved. We work with, half a dozen contractors on a regular basis to either set up scaffolding. The new thing is industrial rope access. I haven't really heard of a lot of people doing spray testing from IRA because it is kind of new. So sometimes there might be an added expense of bringing on a contractor and setting up the scaffold.
Because I've built leak tests before with other engineers, and the engineer firm just basically stands there while the contractor does the water test.
Yeah.
And I'm paying for you to stand there?
Well, you know what? I agree with you. And that's kind of why when we started doing this, we said, well, if it's something we can handle, why are we paying another $5,000, $10,000, $20,000 for a contractor to come in and do it if we can do it? Even if you have two guys on a T&M rate in any of the reputable construction companies, it's going to be, $3,000 or something like that, $3,000, $4,000 depending. So again, if we can do it ourselves, we do. And we believe that our goal is really to save the clients money.
And I think to clarify to your point also, even if we need help with access, we're still running and performing all the testing.
That's why these guys are here today.
No, you see in the picture, they obviously need somebody's help
Yeah.
to get this rig, but that's Ed on there.
Yeah,
So-
that's me. And then we put somebody on the inside. By the way,
I took that picture. Thank you.
I brought some of my team here. So Bill Livingston, James McDonough, Marianne Krisky. The three of them are we'll call it the four of us are like the leak investigation team. So yeah, this is just a shot of us where we had to. This was an interesting one because it had an angled facade, and it's going to be hard for you to see it. But right in the middle here is there was all bad caulk joints. Okay, and we went up and we spray tested them, and yes, they leaked.
All right.
A couple of tools that we use, very simple. Flashlight, tape measure, digital camera, hard hat. But what I wanted to show everybody is, I'm going to sidestep for a second here. Our most fun toy that we play with. Oops, and I'll pass this around. It's a good old thermal camera. So just in case everybody wants to know, I know Alex Argento. We used to work together for an extremely long time. And Alex and I were one of the first guys that started using. Thank you. Yeah, please. This is Bill maybe pass that way. I'll pass this way. So here's hey, hi too. Good to see you. Good to see you. That's the good old thermal camera. So a thermal camera is interesting because it's not a leak finder. It's not a magic tool. All it does is check surface temperatures. That's it. It's not in the movies where you kind of like see through the wall and you see people walking. That doesn't happen. It's all surface temperatures, and the concept, and we'll get into it in a minute. But the concept behind the thermal camera is, if you have an interior temperature that's one temperature, whether it's warm or cold, depending on the time of the year, and then you're spraying cold water, you're going to see, as it starts dripping, you're going to see it build up. And why does that matter? Well, let's just say your leak was coming right through here. Oh, look who's here. James, take her. Right. How are you? All right, good to see everybody. All right. Let's say your leak is coming through here. Well, why is it coming through here? Why is it coming through the air conditioner? It's an air conditioner leak. Well, what it's really doing is it's running on the sheetrock. So when you have two pieces of sheetrock that come like this on a butt joint of a sheetrock, there's a tiny little bevel. And they use that for the tape and the spackle. Well, that same bevel acts as a gutter. So these boards are going to be running, well, the seams will be running this way. So it could leak over here, travel over here, and come down over here. Why am I mentioning this? Because the thermal camera is going to tell us that. It's going to show a giant blue line, okay, where the water is coming from. So that's why it's helpful. The moisture meter is, without a doubt, actually more helpful. There's different kinds. We like the orange one that we're passing around. I like it a little better because let's say you go into a high-end apartment, they have Venetian plaster. The other kind of moisture meter has these two little metal prongs, and you want to start. You have that also? Thank you, Bill. You don't want to start poking holes in someone's extremely expensive apartment. So I like the surface one. We also use something called a borescope, which is basically like a camera on the end of a snake, and you can make a tiny little hole and try to put it up in the ceiling and see what's going on. So there's a lot of tools that we use.
Pokes a hole.
That's the one that pokes the hole. So I'm sure you're asking, Chris, can I? I'm just gonna come over.
Please go be that.
So why do we want this one?
More accurate.
Well, it actually depends on the wall. What if we're in the basement and it's a rubble wall and you have no flat surfaces, or it's a brick wall, and you try to put a flat, so that the orange one has a reader on the back, and you put it on the wall, it might not make a good contact because the wall is irregular. So that's why this one works better. They're all situational. I guess I'll pass it down. There's also a big thought about calibrated nozzles, and there's all these like engineers in the business, and they say, "Oh, I'm a 501. We want to spray test to AMA 501, okay? I don't care about AMA 501. Either it leaks or it doesn't leak.
Amen.
So, are we using garden nozzles? Yes. Do people make fun of us? Yes. Do I care? No. I don't care. I want results. Actually, I have brought one more thing. Brought some toys, some stuff to show. Oh, here it is. So, as the story goes, I went to Boston one time. Here, we can pass this down. Pass this down. This is just what the spray nozzle looks like. And we built this way because a lot of guys have big 10-foot long copper pipes with just some holes randomly drilled that's very uncontrolled. We have this so that we can change or adjust the nozzle to get a line of spray, a cone of spray, and then we have them set up every like 18 to 24 inches with different pipes. Which is kind of more like that, kind of more like this, but we have some photos coming up. Okay, let's continue. So those are the tools. Okay, then the first thing that we're going to do, we get the call, hey, we got a leak. First thing we're going to do is we're going to go to the building and we're going to take initial readings with a moisture meter. That's probably one of the most important things. And then we make little sketches, little drawings on where the leaks occur. So again, part of documenting the process is really important. We also would want to know, has the leak been occurring for a long time? We constantly hear, oh, this has been happening for, years since I moved in. Other ones are just immediate, just a failed caulk joint that might have just finally sprung a leak after years of deterioration. So, but again, what we'd like to do is we'd like to document all the existing conditions. Then when we go to the outside, if it's a roof, we're going to poke around, we're going to look for holes, we're going to look for problems, we're going to look for suspect areas on what it could be. A lot of times you're going to have, roofing. So let's talk about what kind of stuff AKAM would run into. You have a lot of your buildings or existing buildings. A lot of them are going to be brick masonry, I'm assuming.
Yes.
Do we have a lot of curtain wall buildings?
No.
Okay, so a lot of brick masonry buildings. That's good. Because we have some slides coming up that we point out parapet walls and all masonry construction. That's good. But yeah, so we basically go up, we do our initial survey before the testing, and that's when we're going to determine whether or not we can do the test ourselves or if we need to bring in a contractor. We like to kind of get into it. I mean, this is something very simple. This is an EFIS building, and it's a caulk joint, and just over time, they just break down. They just start to fail, and this stupid little caulk joint got into someone's apartment, and then it ruined the whole wood floors, and all the wood floors were buckled. So there's all different kinds of wall types, right? You have brick masonry, EFIS, right? EFIS is one that nobody likes, but there's a lot of it.
Explain that one. Most people
Okay.
know what EFIS is.
Okay, so EFIS is, it's actually EIFS, exterior insulated finishing system. What it is, and it's really a shame because EIFS actually, after I explain it, you would think, oh, we should have EIFS everywhere. And I'll tell you why. EIFS is basically when you have a building and you put styrofoam on the outside, 2 inches, 4 inches of styrofoam, and then stucco. You're going to see a lot of these buildings in Brooklyn. A lot. In fact, most of the 10-story, 15-story new construction apartments in Brooklyn are going to be EIFS. Why is it bad? It breaks down over time. So the stucco fails, the caulk joints fail. And unfortunately, back in the day when it started becoming a little more popular, they never put waterproofing in the cavity behind the styrofoam. And because of that reason, they leak. They leak a lot. And a lot of times it's over metal stud, and the metal stud rots out, and you have bad problems in the building. So EIFS, it can be maintained, and it needs to be maintained. caulking, coating every, call it 10, 15 years. Buildings have to expect to do some kind of repair campaign with caulking, because caulking breaks down depending on what kind of caulking. It could be anywhere from 10 to 15 to 20 years, whether it could be urethane or silicone caulking.
We see that type of stuff more in maybe Westchester or in the more suburban building.
Yes, this was Westchester, by the way.
But so I think that the issue we need to remember here for our buildings, especially in the Northeast, are freestall. And I think that beats the crap out of one of those wall systems.
It does, and the freeze thaw, because of the freeze thaw cycle that we get in New York. So basically, 90 to 100 degrees in the summer. Winter, we all know, is going to be 30, 20, 10. But it basically, those fluctuations in temperature are going to cause the building to expand and contract. Bigger, smaller every year. So you get a crack. Now the crack opens up. And then it moves again. And then it cracks again. And it opens and opens and opens. Yes.
And expand, you can track different materials at different rates.
Right. Okay, let's keep going. There's our thermal camera. So we like to find out after we figure out. Sometimes, believe it or not, the leak is actually a plumbing leak. It's sad, but it happens. We have one that we're going to show in a few minutes that was an air conditioner leak. And we were hunting, and everybody thought it was a roof leak, and it was the air conditioner the whole time. We've actually had a lot of those, right?
Had a few of those.
Yeah, we've had a few of those.
You guys don't do plumbing too, right?
We don't do plumbing. Do plumbing. Yeah.
One-stop shop.
Okay, so let's just talk about the spray testing itself. We get there. What do we do? How do you find it? So water, this might, sound obvious, but water works through gravity. So what you don't want to do, let's say the leak is at this window right here. I'm going to go right to it. The leak was actually through this box, but pretend we didn't know that. You don't want to start spraying up here if your leak is down here, and right? So you want to start at the bottom and you work your way up. A lot of times, we did one in Westchester. We'll talk about it in a few minutes, but they had these leaks in the building for many years, and it was coming 2 floors up. There was these round windows, and the caulk joints around the windows failed. So everybody's hunting like on the 6th floor, and it was really coming in on the 8th floor. So that's why you start low and you go up from there.
Can you tell us about how water travels?
Yes.
Because
yes.
It's not just down, obviously.
Yes.
Right?
How does water travel? Anybody ever see the TV show The Price is Right? Anyone? I'm dating people. Remember the game Plinko?
Yes.
Start bing, 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 bing. That's what water does. Water can run as far as it wants to. I don't know if we have the case study in here, but I do know for a fact that we did one time where they had this like drop ceiling again, or a hung ceiling, and the leak was coming in over here, and there was a hat channel, all hat channels, and it just ran in the hat channel like a gutter until it got to the screw that was holding the sheetrock in and went through that. So water will go wherever it wants, and what everybody should know is that water always takes the path of least resistance. So unfortunately, it's really bad, but there's actually a chance that you could fix something and everything's great, and then the leak moves over here. So sometimes leak chasing is leak chasing. Okay, so what we like to do is spray bars. I like spray bars. Again, we passed around the spray bar. What we do is, you saw it was an 18-inch section. We can add as many of those as we want. They all just screw together. At some point, you're going to lose water pressure. So we like to keep it at 4 nozzles going at one time. And then you move the bar back and forth. Again, there are times where, like this one, we needed contractors to help us hold the spray bars up. it was also an extremely sensitive leak and project. So, you know, when it's that bad, we'd like to bring in certain contractors to help us out and move things along. And then sometimes we get, you know, we're hunting and we have other nozzles that we kind of like put up on poles and areas that we can't reach. But you're basically, a lot of times you're looking for penetrations. A lot of times it's going to be electrical boxes. One of the biggest causes of leaks that I would say, like in a new construction building, the roofer comes in, you flood test the roof, everything's fine. And then what happens? The landscaper comes in, they drill holes through the roof to add the irrigation lines, to add the low voltage lighting. They may or may not caulk the holes. A lot of times they don't, and there's a nice big hole, and all right, well, that's why you have a leak. So, you know, you want to make sure that you're looking for penetrations. There's a hole somewhere, and we're trying to find it. Okay, this is a little more relevant. Okay, now we're kind of getting into a little more of the nitty-gritty here. So this is a typical parapet wall, if you could see that, and different points of the parapet wall are going to cause leaks. So we're going to start at the top and work our way down. What you're looking at here is a parapet wall. There's a nice coping stone, and I think everyone can see all the moss. Okay, so moss is moisture in the wall, and the moss starts growing, and then it grows and grows and grows. And all of this black, moldy, mossy stuff down here is also water that's coming out of the parapet wall.
We have a question from Zoom.
Yep. Oh, question on Zoom. Nadia.
Well,
Hi.
Thanks, Jason.
hi. Thank you. I have a question. So when you are in a situation where you are like locally living is not due yet, so you have 5 years before you put up a scaffolding or you have engineer's inspection and you have a leak, do you consider like drone inspection something that is less expensive? Something like that. There was a conversation about drone inspections like 3-4 years ago, but I don't see that anymore.
Drones are a bit of a sensitive topic, okay? Mainly because of privacy. Very simply, you know, you fly a drone up in the middle of Manhattan, there's hundreds of windows where people, you know, need privacy, and no one knows what that drone is doing.
It's not allowed.
And it's not allowed. You also have to have someone that has an FAA license. And I also heard, I don't know how true this is, but I heard there might be not allowing drones in Manhattan like soon, like next year. Have you heard this? Oh, Eric?
Oh, with the banning?
Yeah, with the banning.
Yeah, it's there. It's going back and forth. They're trying
Okay.
to fight against it.
Right, right. I think once you leave Manhattan, it becomes 100 times easier. But I actually believe, though, and this is just my opinion, I actually believe that, you know, when you do Local Law 11 and you do the close-up inspection and you're getting 3 feet away from the wall, you're going to see something that maybe a drone might not. I really do believe that a set of human eyes are still better. I don't know, Nadia, did that answer the question, or?
Yeah.
Okay.
Yes, it is. Thank you.
I mean, look, I wish there was an easier way to check buildings, and maybe in the future, you know, they will let us use more drones. But I know at the moment there's a lot of red tape. Okay, so back to this coping stone. So,
And just
Yes.
just for people's edification, for those who don't know me, I'm Alex Argento. I run our Florida operations, but we use drones for building recertification and inspections on our Florida properties very often, with wide missing gaps of cost because you can't actually feel or touch or sound what's on the wall. So in many of the engineering firms that you are used to here, TT, Falcon, go through the list, employ that in the Florida market. It's not very successful.
Alex, I agree with you. And also, again, I do believe that, like I said earlier, nothing beats a set of human eyes. And again, you want to get up and touch the wall, literally touch it. I mean, that's why we have sounding hammers and we go up and we literally hit the building with a hammer. I think an acrylic hammer.
Yeah, I think when you're looking at something physically, when you turn your head, the light changes, the shadow changes. When you look at a photograph, in that moment in time, everything had to flatten to produce an image, which is why it can hide things.
And sometimes you have to feel the caulk in the sealant and feel if it lifts up a little bit because it's not actually stuck to things. But a drone can't.
Well, right. That's a very good point.
Metro card in there.
Right. The drone can't put the Metro card in the wall. So what happened here, and this is kind of important. Well, very important actually. This was, believe it or not, this is a new building. It's an existing building that they fixed. Okay. The problem was they actually caulked this joint right here. This is I don't want to say the name, but it's New Jersey. Yes, the New Jersey school. Yes. So what happens is you have a limestone. You have a limestone coping stone. It is eventually water will get through, but right here, if you could see it, it's hard to see maybe all the way back there, but the caulking joint has failed. So it failed. Water came in. Then they caulked all this. Now the water is trapped and it's in this wall and it's just oozing moisture. It's a problem. It's going to eventually break the wall down. They did fix it the right way. Does anybody want to know what is the right way to fix it?
Yes.
The right way to fix it, unfortunately, is you have to take the coping stones off, and then you have to put a metal flashing below the coping stone with 2 little drip edges, and effectively that becomes your first line of defense on the building.
So it didn't have a through wall flashing.
It did not have the through wall flashing, no through wall flashing, and they caulked it shut. And then the caulk failed. It failed up top and didn't fail here, and it was a disaster. They had to rebuild the whole parapet.
When I met you initially, you pointed out the building we were looking at, they caulked the weep holes in a track of a window system. So the thing that was designed to release the water was stopped.
Right. People see a hole and they think, oh, let's close the hole. But unfortunately, a weep hole, if you want to know, is a way that a window system actually drains water. So if you're plugging the drain, it's going to leak. The water can't get out. Yes.
This is visible inside, so possible. If the water's trapped,
It needs food.
Mold does need food. Something organic. A lot of times it's going to live on sheetrock, which has a paper face. When you're up here, this is not really mold. This is moss. It's not great for the building. You're going to find mold on the inside of the building more. Not so much on the outside.
You can erode the bricks or other structures physically, chemically.
Yeah. Okay, so that's basically at the top of the parapet wall. Okay, then you have the next place that it could leak is called the counter flashing, which is basically one of the most important parts between your roofing system, which is down here, and your parapet wall, which is up here. We took this picture because we did a probe on this building, and the way that it works is when you have, this is your metal flashing, which is here. You ever see this detail? So that's a little counter flashing right there. But normally what you do is you have the metal, it's turned up, which is what they should do, but then you should have some kind of waterproofing that goes from the backup wall onto the counter flashing, and they didn't. So in this case, they built the parapet incorrectly because they missed a major component.
Well, but your photo doesn't match your drawing there because that's
Well,
a solid masonry parapet.
Well, yes. That is correct. Yes, this is a concrete block parapet.
So that's a different.
My drawing is a brick parapet, but
Sorry to call you out there.
totally fine. I'm glad you're right
attention.
paying attention and watching. Yeah. So what Chris is saying is you have different types of construction. So this construction here is concrete block. We drew it as brick, but the principle is still the same. you still want to have a waterproofing inside the wall. Okay, and then the third place that it's going to leak.
Before you go
Yes,
there,
you go ahead.
back one.
Yep.
Could I just ask,
Mhm.
what happens if and we see this all the time, if I take that roof membrane and I run it up the wall all the way?
All the way.
Should I do that?
What's that?
Should I do that? Should the contractor do that?
It's not a bad move. It's not a bad move. You know, when I started getting into the business, metal panels were in vogue on the inside of parapet walls and on the outside of parapet walls. Okay, and they just put a big metal panel to try to stop all the water. A lot of times they don't run the membrane up. I'm gonna get a little deep in the weeds here, because the new roofing systems have liquid applied flashing, and what that means is you have your flat part of your roof, and then when you turn up a parapet or up the side of the building or side of the wall, you do a liquid applied product, and those products are extremely more expensive. So a lot of times what happens is they'll just bring it up, let's say a foot, and then any water that might come in through the top, you're relying on this counter flashing here to get the water out. Could you avoid all that and bring the roof up and over? Yes, you could. Yes. But a lot of times they don't do it.
And it doesn't create a problem with the parapet breathing?
Well, it would breathe through the outside. Yeah. Brick does want to breathe. We don't like to encapsulate
Sealing
brick.
it would be a problem for both sides because if water gets trapped.
Agreed. If you have a non-breathable coating, that would be bad. Like roofing. Like if you brought the roofing all the way up and over, that would be bad.
So the liquid flashing is breathable?
No, it's not.
It's not okay.
It's right. It's not breathable.
But so as long as the one side, the right side face is open, it should be okay.
It should be okay. Yes.
So it's really a material savings strategy.
It's a cost savings. Yes. The third place you're going to find leaks are on lintels, window lintels, right? That's probably where you might hear or see, oh, my window is leaking. And the window lintel is, when you have a brick masonry building, it's a piece of steel that goes across the top of the window to carry the bricks above. But what happens is, if you have water that, let's say you have a crack on the outside and water is coming down and it hits this lintel, you want the water to go out. So very important that when you're doing construction, okay, here's our window, here's our lintel, and this is a piece of flashing that we like to add. And then they put waterproofing. And then the most important part of the entire thing, because it's all three-dimensional, is right here where you want to have something called an end dam. And the end dam sends the water out of the building. If someone misses this little piece of waterproofing right here, it was a complete waste of time. Because what happens is now the water comes here, it's going to go sideways and then back into the building over here. And you have a different leak or a new leak. So again, you want to take water. The buildings want to have the water come in and then send them out.
And so then just send it out. So you created the end dam. So then how is the water getting out through the masonry there?
Okay, so when the masonry goes back, there are little holes or tubes. They're called weep tubes. There's two types, round and rectangle. Never, ever, 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 ever use round. Never. Just because they're this big.
They don't work.
They clog. They just clog.
I think we also forget about
And they don't
water
work,
that gets into the building. As it moves, as it travels, it's picking up dust and dirt and things.
Everything in the cavity is kind of like going into that tiny little hole, and it's basically just going to clog on the inside. Whereas the rectangular weeps are about an inch tall, much, much, much less chance of clogging. In fact, they usually don't clog. Okay. Oh, you know what? I want to make one more point. Can we go back to the previous slide? So the other thing, the last thing about lintels, I don't know if I'm stating the obvious here, but if you're doing a lintel repair, it's a lot more cost because you have to set up hanging scaffolding, you have to get a contractor, You need permits. Permits means drawings. If it's an LPC building, of course, a lot of problems with that. We have to go through the whole process. So when you have like a really high-end landmark building, it's going to be expensive to fix, unfortunately.
And would you agree that over time that lintel could potentially fail structurally? I mean, that would be an extreme case, right?
It would. Usually what would happen first, this is just my opinion, I think if a lintel started rusting, they start to delaminate. Okay, and as they delaminate, it's called rust jacking. That cracks the bricks. So you're going to see the bricks crack sooner than the lintel failing, like literally failing. I mean, I've seen bowed lintels that are, an inch, bowed, bad. That's definitely a failure, but it probably could have been, diagnosed and found out much earlier. If it gets that bad, if it gets to the point where the lintel is failing, then there's neglect. Or maybe somebody just didn't know. Any other questions? Because in a few minutes we're going to get into a couple of case studies, and I'm hoping they might shed some light on maybe some projects that buildings that you might have, or, oh yeah, I got that problem on my building. Any questions so far? Okay. So when we're doing the leak investigation, the other thing we like to do is put a report together. It's very simple, but people want to know what's going on, what's happening. Why is this taking so long? How come it's not fixed yet? I'm calling my lawyer. Right? Northmore. Not Northmore. Late. What was their name? The people that lived? I forget their name. But they had a leak, and after like 2 days, they're like, I'm calling my lawyer. This is unacceptable. Unacceptable. So what we do is we produce reports so that you guys can say, look, we're on it. I understand it's unacceptable. I get it. We're doing something about it. Look what we're doing. So that's why you want to have deliverables to send out to your clients and boards, condo boards, and say that we're actively working on this to solve this problem. So once you figure out the leaks, then we get into the whole repair campaign. Now, repair campaigns could be simple, or they can be very complicated. This was, a green roof that we were looking at. It was leaking into the parking garage really bad, and it was the drain flashing. So we had to, make some probes, open things up, find out what's going on. Keep going. My favorite, preventative maintenance. So you see me standing here on a roof, literally full of water, literally. And was it leaking? Yes, it was leaking all over the place. And I was like, and unfortunately, it was a self-managed building. They didn't have no super, no nothing. And I felt obligated. I went up there. I'm like, all you got to do is just move the debris away, and this is going to drain. And the lady said, yes, please. I said, okay. Should I be doing this? I don't know. Do I think it's the right thing to do? Yes, it's the right thing to do. So, yeah, we do what it takes. This was another one here. This is Northmore. So again, leaking into the penthouse. It's always in the penthouse. Don't ask me why. But this was a clogged gutter. Gutters, so maintenance. The biggest thing that I hope that everybody could take away from this meeting today, very simply, is twice a year, send your super up to the roof. Send them up there. Clean the drains.
So every time we have an upcoming storm, where we're expecting heavy rainfall, we do inform all of our supers to check their drains aside. So we're dealing with water and wind. And so we want them to check their drains. They want to make sure, they batten down the hatches. But most importantly, like you're saying, that all drains are clear.
They have
because they are flat roofs most of the time in our buildings. They're designed in some ways to act like a bathtub, but if they don't have a drain, they will fill up. Those roofs are not really designed. They do make roofs designed to hold water but drain it slowly, but most of our roofs are not designed to hold water while it drains.
Right.
So situation like here, we're seeing you're fixing.
And I would add to besides the drains, you'd want them to look at the way sediments will collect under pavers in particular, and that will impede
That's a
the
big one.
movement of water and can allow water to build up and pool even against building walls and such. So under pavers can get really filled up.
Yeah, I think we see a lot of issues in our buildings with ponding water. We see a lot of issues where there's sponginess underneath. You're walking on modified bitumen roofs. I think are probably one of the most common roofs we see. So they also require the most maintenance.
Yes. Bill made a very good point. Roof pavers. You have a terrace. If you don't clean the pavers, it's just natural soot in the air, and it literally collects between paver joints on roofs. Then the moss starts growing. You have a nice little green roof. It's gorgeous. However, then it doesn't drain, and now you have a bathtub with like a plug in it. The water comes up, and what happens? It goes in your terrace door, leaks all over your herringbone, Brazilian cherry wood floors. So, yeah, I think checking drains twice a year, and maybe every 5 years you want to have pavers lifted and cleaned. Just clean the whole damn thing. Power wash the roof down, put the pavers back. It's like a 5-year thing. Let's continue. All right, so we're going to get into a couple of case studies. This is a building down in Tribeca. Billy Crystal lives here. One of my goals is to meet him. And this is kind of funny. This is the day that we had those, remember those Canadian wildfires? Remember that? And the sky was this color. So here we are outside, and we're spraying, and we're doing controlled testing. We're looking at all penetrations. Where could these leaks be coming from? We're starting at the bottom. This is the roof. We started spraying all these outlets. We came over here with an extended wand, and we started spraying here. This actually had multiple leaks, unfortunately. Next.
This also had the roof built like a new roof. That building had also been raised about 2 floors.
Yes, they raised
so
2
there was
floors.
an old roofing system at that level that wasn't closed up properly. And
So-
possibly
This one we had a contractor helping us out because again, it sensitive owner, and but again it was multiple leaks, unfortunately. This is another one that we're doing on West End Ave. This is a fountain, and the fountain actually is leaking. It's not holding water; it's leaking all over the place. And so what we ended up doing was we did a dye test, a red dye test, and we use the thermal camera. Okay, you can see what it looks like here with all these cracks and all this efflorescence indicating previous leaks. But the thermal camera really pointed out where it was coming in exactly. And then the dye, it's hard to see, but the dye is actually on the wall and it was pink, and we knew, hey, we've recreated the leak. So if I didn't say this earlier, our main goal is to actually recreate the leak. Because if you don't know where the leak is coming from, how are you supposed to fix it? Right? They might say, oh, we need a whole new roof. No, you don't need a whole new roof. You need to just caulk around that door saddle and that's it. So again, we want the building to leak when we're testing.
I think we should all remember here that it's in the contractor's best interest to say you need to replace your whole leak, because that's a lot of good work for him.
Yeah. So then this was just, we took a little sample and water started gushing from under the membrane, which told us, all right, unfortunately the membrane has failed. Next. This is an AKAM building. This is in Westchester. So this is an interesting one. And in fact, I think Chris is the one. This is the one that you might have mentioned. So I say, Chris, give me your worst one.
This one's the worst one.
Show you what we could do. And can we just go to the next slide? Yeah. So this was this person's living room. And buckets garbage pails in their living room. And as the story goes, the person had to, like, every time it rained, they had to sleep in the living room and move the buckets and empty the buckets. And we came in and we spray tested, and we started, let's start at the door saddle, and we worked our way up. But again, this ended up being something that was coming in 2 floors above. So we just have to always be thorough. This one, we needed a contractor to come in and, put up a pipe scaffold. So this is that EIFS wall. This is a light fixture on the outside. And what we all believe happened was they built the building, and then the contractor put the lights in later, because when we took this apart, there was a huge hole where the electrical conduit came through the wall. They didn't seal it. I think what they did was they just drilled the hole, and that was it. This is another AKAM building. This was there's a pool leak. There was a leak all the way up, like at the top of the building here.
Murray Hill Muse.
Murray Hill Muse. We did some testing. This was the video of the water coming through. This is a shot, because it was a few floors down. We did have to get a contractor involved. This is a shot of them spraying the outside of the building. This is a shot of the water coming in. We're about to go through the repair campaign now, which is going to involve taking out bricks above the window. This is the pool at the building. And, obviously that's the roof. And here we are spraying. There's the video of, the drops of water going into the roof. Who took that video? James, is that you?
Yeah.
Nice video. Thanks. Nice catch. So this will all be part of the repairs. But you know what this is? Just go back quick. This is failed caulking. Okay, so you have all this metal. Metal doesn't leak, ever, 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 ever. Never. It's the joints between the metal. And when the sealant between the joints fails, water comes in.
How frequently should joints be refreshed, or is it very specific to the type of
Yes.
joint?
So that's a great question. So in the biggest picture, there's kind of 2 types of caulking: silicone and urethane. Everybody loves urethane. Silicone lasts 100 times, not 100. Silicone lasts, let's say, 15, 20 years. Urethane lasts 5 to 10. Why would we use urethane if it's only going to last 5 to 10? Why would we do that? Money. It's money, preparation. Silicone's a lot harder to work with. You have to prime it. You have to do a much better job. The urethane is a lot more forgiving, a lot easier to install. It's also very sticky, and it sticks to the bricks and coping stones a lot easier.
Which type of product is MP1?
NP1 is urethane. NP1 is urethane. So NP1, and everybody says NP1, right? It's like Power Pro, NP1, Blue Skin. There's, the Coca-Colas of the building envelope world. Everything has its place. Okay, the urethane is better inside the cavity where it's not going to get hit by the sun. So the problem is with all of these products, the sun is what really hurts the building. It's UV degradation. And unfortunately, urethane, NP1, is much more light or UV sensitive. Much more. That's why it's like 5 to 10. So when you're all managing your buildings, you want to think, okay, I have this building, and I'm not asking for you to say, oh, what kind of caulking do we have on the coping stones? Who knows? Ask your architect.
He doesn't know.
but you want to be able to say to yourselves, hey, if we're going to maintain this building to avoid leaks in the future, we kind of want to have like a 1 year, 3 year, 5 year plan. We're going to get to that in a little bit. Keep going. How are we doing on time? Oh, we're almost out of time. All right, let's speed it up.
What's the last?
Okay, this was the one, this down in Tribeca. Again, they thought it was coming around this exhaust fan. Next. and we ended up doing flood testing, and we found out the membrane was peeling up. Believe it or not, do we have the slide with the pipes? We did a green dye test. There's the water coming through. So that was the, around the fan. This is just more shots of thermal cameras, moisture meters. This is us saying like, oh, we have a problem here, a problem here, a problem here. Marianne, that's you, right?
Yeah.
Right? She wrote 60 to 80% right here. Use painter's tape, so we're not really hurting anybody. All right, let's talk about the summary and the takeaways. That's a funny picture. I think the summary here, when you're managing a building, okay, and actually I have questions for all of you, believe it or not, because I want to know. You're managing a building, local law 11 is coming. Let's say you had a safe building. We're in cycle 10. Let's say cycle 9 was safe. Chances are somebody's going to find something. Chances are. What I would love to know or hear is, do you see yourselves, nobody wants to build up the war chest, the capital reserves. Am I saying that correctly, or
You are.
okay? And the capital reserves obviously come from the residents,
Right.
And if they're paying, I don't know, I'm making this up, $1,000 a month or $5,000 a month, whatever it is, the amount of money that you see buildings saving in their fund, is it enough? Is it ever enough? We're always doing assessments, right?
So we recommend
Yeah.
a 6-month reserve if feasible. We do recommend that maintenance, charges escalate over time because then you are going to need that money. We also do capital improvement budget estimates for future work, and they do include setting aside money for investigations, inspections, and potential remediations. And then, like you just said, we also suggested that you might get a safe cycle. It's your leapfrogging, safe to unsafe,
Right.
or I should say
Safe to swarms. Yeah, every 10 years you can have a
So
swarm
yeah,
building.
we're going to do some work, and
Yes.
and people that they often will get bothered by the $1 million plus price tag. But I like to remind them that their building is in its second, sometimes third, or sometimes fourth life. The building this morning is literally 100 years old this year. That's going into its third life cycle.
Right.
And buildings, physics never stops.
Right. I think that it would be great if more buildings took a little bit more of a proactive approach and said, "Hey, I understand we have a safe building. Why don't we do a mid-year mid-cycle review?" I don't think it costs a lot for an architect to come to a building and just do a visual review and just at least tell everybody, "Hey, listen, I want you to know, like caulk joints and coping stones, nobody's really going to put that in your FISP report."
Part of the issue that the part of the issue that we see, I think, are as soon as you write it down, it's now discoverable. You mentioned this early. We're a very litigious society now, and everybody's always worried about if a non-board member, a resident, gets a hold of something, are they going to then force this work to happen in the building? There's a fiduciary responsibility. So it's a constant threading of the needle. One thing that we have done proactively is go out to all of our buildings for code compliance and life safety, because obviously we don't want it to get hurt. Number one, and
Safety is always number one. Yeah.
Number two, then the liability if somebody in your building isn't code compliant and they get hurt. I think the next layer would then be non-structural failure, as Jonathan Hochschwarm would say, what you're talking about. But I agree that, being proactive, I don't think people often realize just the entropy that is deterioration in the building. The longer you let it go, it doesn't stay on the same trajectory. It actually spikes.
It's exponential.
Right. Which is like the garage failure we saw in Lower Manhattan, and
Yeah, now I heard White Plains had a failure. That was a bad two, right? Yeah, I heard another one. I saw it on the
I
news.
think they're often though in the, I'll say they are pre and post tension concrete, so it's a little bit of construction there, but still, yeah, it's neglect.
It's neglect. It's waterproofing. It's, I'm sure you all deal with parking garages, right? It's
A lot.
It's cars driving in with water and salt. It's salt on the tires that come in, and then it sits there. And a lot of times these parking garages have no waterproofing whatsoever, none. And then over time, it starts with spalls. But look, I hate to say it, it's a business for them. They, if they're losing revenue on parking spots, they're losing revenue. So they don't want to really, but they need to maintain it. They have to. It's an asset. That's part that I'm trying to understand. I actually have one more question for everybody. Do you see like what happens when you get the phone call, the leak? My building is leaking. Are you getting it from your super? Are you getting it from a board president? Like who's calling? And then what? The leaks are never easy. Never, ever. Never.
But the other thing that's interesting though is that you're an architect, and I could tell you, to be perfectly honest, I worked in New York City for nearly 20 years before coming to AKAM. I've learned more about how to maintain buildings by working here in 5 years than I learned in 20 building, which is insane to me. And there aren't a lot of architects and engineers that are out there doing what you guys are doing, which is looking at how these buildings fall apart and thinking about how to extend that life of the building. I mean, these are incredible assets,
Right.
And as soon as they were built, they start falling apart. And to be frank, we don't know a whole lot of people that are doing what you're doing. And if you have other recommendations for us as well, we'll take them too. Because I know you guys can't be in 100 places at once, but our buildings are not going to stop falling apart.
Right. And again, the maintenance, doing that visual, doing a visual inspection, even if it's once a year. It's like, hey, we're just going to go poke around. Let's go look at all these terraces. Let's look at all these parapets. Let's make sure the railings are okay. It's basically more like a limited FISP inspection, but do it. And because again, you could have something, and then all of a sudden, like you do your FISP inspection, and then 6 months later, something goes wrong. And that's why I'm saying, once a year is pretty good to do.
Is that something that you guys do?
We're actually, what's funny is I'm trying to develop a annual maintenance program where, for example, like, March and October, check your roof drains. Okay, go up once a year, shake all your shake all your railings, make sure your railings are not loose. It can happen. And
I think a lot of our boards would say, isn't that the resident manager's job? But that's so, and I would wonder if also, aside from that program like you're trying to build out, which is also incredibly useful, especially when they don't have an on-site resident manager, which does happen in several of our buildings, maybe possibly training for resident managers, a training class of some.
What to look for.
Exactly. So we try to do that whenever we can. Red flags under things. We normally are done training here on emergencies. And red flags, but I think maybe you guys would be perfect with regard to the deterioration in the envelope of the building, and we can have a class on that. That might be useful.
Okay.
Let's take a class is a great idea, and any way we can do ongoing maintenance suggestions is a great idea. I'm also thinking about there's the annual parapet inspection.
right,
They're
right.
ongoing now.
Right,
It's a
yeah.
good thing. It's a little bit like a freebie, but you have to hack it.
Well, we
And
do.
you often identify issues that you might want to know about, especially because that's something that's ultimately shared just between management, you all, and us. It's not filed with the DOB.
Agreed.
So it's sort of a nice chance to identify, especially on the facade and parapets, preemptively. Yeah.
When we do our parapet inspections, we kind of check everything. Check the roof, check the parapets, not just the parapet. Check the bulkheads. Poke around. You go into the building, go check it out. Again, preventative maintenance could just save a lot of money. And
have you guys developed any? So the thing that I personally see in the industry as a problem is there's not enough data to justify the cost. So I think more architecture firms, engineering firms, if they were collecting data, hey, this year we did this maintenance, this maintenance, this maintenance. So, for example, there's dozens of white glazed brick buildings with chamber corners throughout the city, right?
Sure.
So one developer made them all right over right. What would be interesting is if you had one, it's just as an idea, if you had one client who actually was in your program and another one who wasn't. And then you could see how much money these two buildings that are nearly identical ended up spending. In general, it's a lot easy for us and our managers to sell things. We could say, hey, look, this project went this way and we saved you $50,000, and this project went this way. You didn't use our property management group, for example. You used a bad vendor, and now you're in a situation where all your load centers and your units aren't grounded, or whatever it is. Fill in the blank. But if you
Or you got to start over because they did the wrong thing. Or something,
correct.
You know?
So I think having that data is the way that makes it far easier for us to sell to our clients. So we would recommend that you guys think about that as well.
Sounds good. Okay. Any other questions? I don't want to take up everybody's time, but if anybody has any specifics, we're here.
Can you leave a few cards for everybody?
Yes, of course. Yes. No problem.
Thanks, guys.
All right. Thank you, everybody. Thank you.